Okay, so we're looking at stem and leaf plots and dot plots today. So there are other ways of displaying our univariate data. So remember, univariate is we'll have a list of data, and so that's a way of displaying it. So we've got a stem and leaf plot can be useful in displaying when you've got two lists of the same values. So say, for example, you had, say the staff here at Bernard's, you might have the male staff and the female staff and their heights. So because it's the same thing, you might use it because you can use a back-to-back stem and leaf plot. So let's just go through what a stem and leaf plot is first of all. So we've got an example here. So the stem will indicate the first digit in the number. So a stem and leaf plot will be numerical data. And so the stem represents the first number. Now it doesn't necessarily, so you need to have a key so that you know what the number is. So you see here it says 2-2. So you know that the stem part is a 20, means 20, and the leaf means 2 units. It doesn't necessarily have to be that way. So say I had another stem and leaf plot. I might have, and I could have it like this. I'm still not. Okay, and then if I put a key, and I might put a key and say 1-9 equals 1.9. So can you see, like, it actually means that those numbers are all, the leaves are all decimal places. So so that's why you have to have a key. So if you're asked to do a stem and leaf plot, you have to have a key to tell the reader what it's demonstrating. Now, if you look at it as well, you'll see that the leaves are all from lowest to highest. So they have to be, the leaves are lowest to highest in numbers. So you've got to, you have to put them in order. So really, this stem and leaf plot shows the whole list in numerical order from lowest to highest. So if you were counting up how much data we actually collected here, so say they've collected the ages of all these people, so how many people did they actually survey? You just count the leaves. So there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 15 people, ages were collected. And we can see quickly on a stem and leaf plot, we can see quickly the youngest person was 16 years and the oldest person was 61. So it's a good way to display the data, because if you gave me just a list of all that data, I can't really look through it and see. This way I can see a lot of things. Now, also with a stem and leaf plot, we can comment on, and we like to comment on things like its shape. Now, I'm just going to show you here. If I grab this stem and leaf plot and flick it on the side there, so can you see, this sort of looks like our histogram, doesn't it? Where we had our numbers along here. Yeah, so we'd have, say, between 10 and 20, category. So then you can see, you would have the towers. They would look like that. And you'd have this frequency along here. So looking at that, say that was a histogram, what type of shape does that look like? So remember, if I draw a thing, what type of shape does that look like?
Symmetric.
Yeah, that looks like approximately symmetric. So we'll just say it's symmetric. That's okay. All right, so that's why a stem and leaf plot, we can also comment on the shape. We can flick it, so we would say this one is symmetric. Yeah, so if you want, you might just draw across like that so you can tell, you can remember. All right, so I'm just gonna talk here if we had a back-to-back stem and leaf plot. So if we had a back-to-back stem and leaf, so if you've got a bit of space, you can draw this. So as I said before, we might have, say, the male heights and the female heights. Okay, so what we would see is we have our stem, and we might break it up. So we might have two ones and then say 2. So I might call this, so I might say, wait a minute, sorry, yeah, and then I might, okay, and then I've got maybe, okay, so, and then I'll put a key here, and what I'll say is 1-5 equals 1.5 meters. All right, so here we've got our females and male staff. So here you could look at it. If we were commenting on the shape of the females, what would you call that? Symmetric. Good. What you need to be careful with this one, if we look at the males, so if I just go and cut it out like I did before, if I turn this, I can't turn that around. If I turn this around, can you see that the lowest is not at the start? This is the lowest, isn't it? So actually, if I drew this as a histogram, I should really have 1, 1, 2. So I see this big tower at more near the end. So this one, it's not, I didn't really put a lot of data. We might say that that is more negative skewed, but just be careful. This one is the reverse of that. Now, also we can see other things like who there was more staff. We can see we had 1, 2, 3, 4. We had 5 female staff, and how many male staff did we have? We had 2, 4, 6, 7. Okay, so you can see things like that and see how it's distributed. So that's a back-to-back stem and leaf plot. So really good when you have a set of data where you have 2 sort of categories. All right. Okay, so we're going to construct a stem and leaf plot. It said the following set of marks were attained by a group of students for a test. So display in a stem and leaf plot. So you would first, you're going to draw out your stem and pop all the stems in there. So the lowest is 2, a mark of 2, and the highest, it looks like it's 60. So I might just do it in 10. So I'm going to go 0, 1, 2, 3, 4, 5, it's not long enough, and 6. Okay, so I'm going to start with the lowest one, which was 2. Now remember, these leaves need to be in order, and they also have to be underneath each other. They need to line up so that you can measure, look at the shape correctly. So then I think there was, what was the next one? 3 19s. So 9, 9, 9. And then there was a 20. So I have a 0. And then I had 24. Did I have 2 of them? Yeah. And then I had a 25 and a 25. And then 3 28s, was it? Yeah. 1, 2, 3. And then a... Anything else? No? And then a 30. 33. A 35. 2 35s. A 36. A 38 and a 39. And then I had a 41. 42. So you can see my leaves are underneath each other too, and that's very important, otherwise the shape won't look correct. And then I had a 60. So a few things to point out here is when there's a gap, you just need to leave it. It has to be like that because there was none in that category, but you still need to have that 5 there like that so we can see. So we need also to create a key. So the key, and I'd say 1 dash, doesn't matter what number you pick, and you might say equals 16. I should label it. I'm just going to call it marks because of a test. Now there's a few things we can look at. So if we look, what shape do we think this is? Symmetric, but what about this guy? Good. So we'll probably say this one is symmetric with possible outlier. We'll just say possible outlier because we're not really proving, we don't know yet if it is an outlier, but it looks like it, so we'll just say possible outlier and you'll get a mark for that. Okay, so this is what I'd be looking for, is that your leaves are all lined up like that, nice underneath each other, that you're in numerical from lowest to highest like that you have a key and that you've labelled it. So it'll probably be about 3 marks on a thing. Alright, so here we've got an example of a stem and leaf plot, and it said the marks of 23 students, and I think it actually was the one we just did. Okay, so that they've done the stem and leaf plot, and they've talked about the shape, and over here they've said approximately symmetric with an outlier. That's what we said. Now, they often ask you to say what the centre is. So when you're asked for the centre, you need to quote the median. So that's where you've got to say what the median is. And the spread, we'll do more of this later, but with the range and all that. So let's just find out, let's just write here what we did on the calculator. So we, on the calculator, oops, sorry, oh my God, what have I done? Okay, on the calculator, what we did is we went into lists and spreadsheets, and we went into lists and spreadsheets and we wrote our list in. So we had the marks, we called it marks, and then we had, so 15, 19, blah, 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 blah. Okay, so this is the first thing we did. Then once we'd done that, when we wanted to get the stats, so we pressed menu and we pressed stats, and then we did stat calc, and we picked one variable, okay, and we clicked OK for one list, okay, whatever that was fine, and then we chose our mark list. So where it said what list, I think it said, it referred to it as the X list or whatever, and we chose that and we pressed enter. So then what we saw then on our page is we saw this, and that is, you might write that's the mean or the average. And we also went down, and if you move down you'll see we saw minimum and things like that, and we also saw the median and the max and all that. So you could find all your values there if you need to. Alright, so you've written that, you can remember. So just while you're writing that down, I'm going to look at, so sometimes we get asked to write a report, we'll look at that later. So that stem and leaf plot, we already said it was symmetric with an outlier. We could say the centre was at, what was our median, 23 was it? No, 28. On our data we had 28, so, and then and things like that. All right, this down here, this is a question 2. It said the developers record noise levels in 2 proposed residential sites. The results are listed in a back-to-back stem and leaf plot. Which of the following statements is true? So they ask a lot of things about what we can see is a median or interquartile range, which we'll learn a little bit later. But what I want to show you on here, if you were trying to find all that data, like the median and all that, what you could do is you could put it in lists and spreadsheets, and you could have site A, and and what you would do is write in all the numbers. So I know from the stem and leaf I had a 34, I had a 37, a 42, a 52, and so on. And can you see how you could have created a list and then gone and done this menu stats and got the stats that you'll need to answer that multi-choice? And then I could have also created the list for site B. Site B's lowest would have been 37, then you would have had 39. And what would the largest one on site B be? Good, 78. And what would the largest on side A would have been? 78 as well. All right, so just to show you, that's how you could handle that question. If you can't manually look in there, and sometimes that's a little bit hard, then just know to go type the list in and then you can find all the data you need. So let's just have, this was a back-to-back stem and leaf plot. So the test scores for Mr. Brown and Mr. Voss maths class were recorded below, and compare the distribution. So what they did is we typed them in and we had a look at the distribution. So we could see that Mr. Voss's was symmetric. Now we see that in Mr. Brown, it starts off low and then gets high. So in a histogram, when we start off low, so we have little towers and then we get larger, what type of shape is that in a histogram? When you have a tail and then it goes like that, it's negative skewed. And that's why we're saying this one is negative skewed. Okay? And then we've talked about the center. So what they did is they found the median of both those lists. So Mr. Brown's median was 36.5 and Mr. Voss's. So they just type the list in and you can do it in your calculator. The spread is when you just say the range. So the range is the largest minus the smallest. So say for Mr. Brown, the largest was 48. So the range was 48 minus the smallest, which was 19. So 48 minus, we've got the wrong things in here. So what's 48 minus 19? That is, this is not right. Just cross that out. That's not saying that's right. So his range was, what was it? 29. Good. And this one's range, Mr. Voss's range was, what's the largest? 50. Smallest? 8. So he had 42. Okay? We'll do a little bit more of that, but just so you could see. The last bit we're going to do is the dot plot. So we'll do this on the paper here. You could type this into your calculator, this list, and we've done it there, and we could create a dot plot and it's written there. Just be careful when you're drawing it up on your page. Remember to have a ruled number line. So I'd have to rule out this number line and have it nice and even. Then I put my numbers underneath. But you always have your calculator, so just do one on your calculator and copy what that calculator is saying. Okay, so mine's not quite long enough. Okay, and then you just have a dot for everything. So, because there's a 21, there's a dot, there's two 22s, there's a dot, and things like that, and so on. You can read off the shape of this. So this shape, it sort of has most of the data at the start and then it tails off. What type of shape is that? When you've got a bigger chunk at the start and then it goes low. What's that? Yeah, good. So that one is positive skewed. Okay, boys, you're going to work on to F today.